Hello, this is Dr. Baxley. Here's an answer key for the in-class worksheet in Chem 201X in week number 3. The first problem asks us to calculate how many atoms are in a piece of nickel. We know the density of the nickel, and we know the measurements of the nickel piece in terms of inches. If we're trying to calculate how many atoms are present, we might be able to get that from moles. We might be able to get the number of moles from the mass using the molar mass. We might be able to use the density of the nickel in grams per cubic centimeter if we knew the volume in grams per cubic centimeter. So we can start by calculating the volume in cubic inches by simply multiplying the dimensions in inches together to get the 1,176 cubic inches. Now we're limited to 2 significant figures via one of the measurements, so we know we can only go to the nearest hundreds of cubic inches in this particular problem. Once we have cubic inches, we can convert to cubic centimeters. And don't forget to cube the conversion factor of the 2.54 centimeters per 1 inch to make sure that we cube all of the 3 dimensions of the object. Once we know the volume in cubic centimeters, we can multiply by the density. To find the mass of the nickel, we can use the molar mass of nickel to find the number of moles of nickel. And we can use Avogadro's number to calculate the number of actual nickel atoms present in that piece of nickel. Turns out to be an awful lot. 1.8 times 10 to the 27 atoms, limited to the 2 significant digits we had before. The next problem asks to calculate the molar mass of titanium 4 phosphite. It's really important at this point in the class that you're able to translate names of chemical compounds to formulas of chemical compounds. Titanium is Ti. The Roman numeral 4 stands for the charge of the titanium ion in the compound. Phosphite has 1 fewer oxygen because of the ITE suffix than phosphate does. So phosphite is PO3, 3- as an ion. In order to determine the formula of the compound, we can look for the lowest common multiple between the 4 plus and the 3- so that we can end up with a formula that has the same number of positive charges as negative charges. The lowest common multiple between 4 and 3 is 12. So we can have a formula for the compound of Ti3 PO3 4 for the titanium 4 phosphite. For the molar mass of that substance, we need to look at the molar mass of 3 titanium atoms, 4 phosphorus atoms, and 12 oxygen atoms. We can get those molar masses from the periodic table. Here is titanium. Here is phosphorus. And here is oxygen. So here are the molar masses for each of the 3 elements involved. And I always encourage students to use 2 decimal places for all the molar masses on the periodic table. That usually gives you enough information without burdening you with too many significant digits. We can then multiply all these values by their appropriate number, 3 for titanium, 4 for phosphorus, and 12 for oxygen. And we end up with a molar mass of 459.49 grams for every 1 mole. Next question asks about the number of moles of nitrogen in a certain amount of calcium nitrate. Again, this shows you how important it is to know the formulas of compounds based on the names. For calcium, we can determine the charge of calcium based on its position of the periodic table. Here's calcium on the periodic table. It's in the second column over, 1, 2, from the left. And so most of the elements in that column get a 2+ charge when they form compounds. Those would be magnesium through barium. Beryllium doesn't really make ionic compounds, and no one ever uses radium for anything because it's too radioactive. So we know that calcium is 2+. Nitrate is a polyatomic ion you should know the formula for. It's NO3-. In order to get the charge of the compound to be 0, we would need 1 calcium ion and 2 nitrate ions. So there's 2 positive charges and 2 negative charges in the compound. We can then start with a measured value, the 33.7 grams of the calcium nitrate. We can multiply it by the molar mass, calculated just like we did for the titanium 4 phosphite. And then we can multiply it by a ratio. For every single calcium nitrate substance we will have 1 calcium ion and 2 nitrate ions. Since there's 1 nitrogen in every nitrate ion, we know that there's a ratio for every 1 mole of calcium nitrate. There will be 2 moles of nitrogen atoms. This calculation gives us the answer of 0.411 moles of nitrogen atoms. We're going to change directions now and look at some names and formulas of compounds to make sure that you're well practiced with chemical nomenclature. If you haven't looked over the lists of ions and elements that you need to know from your instructor, you should probably do that right now. There's no point in working on these problems until you've really done some good work in terms of learning the names of those elements and ions. So, you've learned those names, let's get started. The Al is short for aluminum, and the SO4 substance is sulfates. So the name of that compound is simply aluminum sulfate. Aluminum is one of the elements that follows the rule that it always makes a +3 ion when it forms compounds. You can see that based on its position of the periodic table. Sodium makes a +1 ion, magnesium makes a +2 ion, and aluminum makes a +3 ion. Next compound, Na3PO4. The Na is the Latin name natrium for the element, but we call it sodium in English. And the PO4 is phosphate. So the name of that substance is simply sodium phosphate. The P2Cl7, the next compound, is a compound made of nonmetals. It follows slightly different rules. Since the nonmetals are not ionic, meaning the atoms don't have charges, we have a different set of rules for naming those compounds. In order to tell us how many elements are present, we use some Greek prefixes to describe how many of those elements are present in that type of compound. Since there are 2 phosphorus atoms, we call this one diphosphorus. There are 7 chlorides, so that's heptachloride. The 7 is shown with the prefix hepta, kind of like heptathlon, if you're a track and field fan for women's sports. CuOH2. Cu is short for cuprous from the Latin term, but we call it copper now. And copper is one of the elements on the periodic table that you can't identify the charge of. So here's copper. That's one of the transition metals. We can't tell what its charge is going to be just based on its position on the periodic table. However, we do have enough information to decide what the charge of copper is. Hydroxide, OH-, is one of the ions you should know. And it's got a -1 charge. There are 2 of them, so we know that there are 2 negative charges, meaning that the copper ion has to be a 2+. In order to tell us what the name of this compound is then, we use the charge of the metal ion as a Roman numeral right after the metal ion. So this one's called copper-2 hydroxide. If you haven't learned about that Roman numeral system, you ought to check out the notes or the text and make sure you're familiar with it before you try the next 4 questions. For iron 3 carbonate, we know that the Roman numeral tells us one thing and one thing only. The Roman numeral 3 tells us that iron, Fe, has a 3+ charge. Carbonate is an ion you should know. It's CO3, 2-. The lowest common multiple between +3 and 2- is 6. So the formula needs to have 2 iron ions and 3 carbonate ions in order for the charges of +6 and -6 to be equal to each other. For chromium-6 oxide, the 6 Roman numeral tells us one thing and one thing only. It shows the chemist that the chromium has a 6+ charge. Oxide from the periodic table is another one we can determine. It's just the anion of oxygen, and oxygen is 2- when it forms compounds. We don't need to worry about a lowest common multiple for each element. We can see that that's going to be 6. So this compound's formula is going to be CrO3. So there's 1 chromium at +6 and 3 oxygens at -2 to make the +6 and -6 needed to be 0 for the total charge of the compound. Mercury's symbol is Hg. I like to think of Mercury as the messenger god, or kind of like the Flash superhero. So Mercury's kind of like the hot god, Hg. That's why I remember its symbol. Pretty silly, but it's how I do it. Mercury 2, the 2 tells us one thing and one thing only. The 2 tells us that mercury has a 2+ charge. Acetate's an ion you're supposed to know. It's C2H3O2 and has a -1 charge. So the formula for mercury 2 acetate is Hg with 2 acetate ions. Gold has a symbol of Au. Gold is the most awesome element, and just like Aurors in Harry Potter books are the most awesome wizards, it gets the symbol Au. Gold 3, the 3 tells us one thing and one thing only. It of course tells us that gold is 3+ as an ion. I'm glad you're catching on. The cyanide ion is another one you're supposed to know. Cyanide is Cn-1. So the formula for gold 3 cyanide is Au Cn sub 3. Make sure you have parentheses around the cyanide. An answer of AuCN3 without the parentheses shows that there's 1 gold ion, 1 carbon atom, and 3 nitrogen atoms. The parentheses are necessary to show that it's 3 cyanides. Next question, calculating the mass of a certain number of molecules of hexylamine. If we're supposed to calculate mass, and we have a certain number of particles, that's probably a pretty good clue. We're going to need the molar mass of hexylamine. So I've calculated the molar mass of the hexylamine right there. We can start with the measured value, the 6.27 times 10 to the 19th molecules. In order to use the molar mass, we need to know the number of moles. We can use Avogadro's number for that. Once I've calculated the number of moles of hexylamine from the number of actual molecules, I can then use the molar mass to calculate the mass in grams. That works out to be 0.0105 grams to 3 significant figures. And I can convert that mass in grams to milligrams using the conversion from Chapter 1 in Table 1.2 to get the answer of 10.5 milligrams. I learned I only get 15 minutes on the video, and I'm almost out of time, so I'll come back to this problem next.